Okay, so we've learned how to write the names of formulas, nomenclature. We've learned how to name type 1, type 2, and type 3 compounds. Now we're going to learn how to go backwards. So now we're going to be given the name and we have to write the formula. Biggest thing that you need to do with these is when you have a type 1 or a type 2 compound is write the ions first, and that'll help you figure out the formula. For the type 3s, you have to figure out that you have nonmetals and then use the prefixes to name or to write the formula. Okay, let's try some examples. So potassium permanganate. Okay, looking at potassium, you should know it's K for potassium. And then you should think, I can predict the charge of that ion. It would have a charge of +1. So first thing, again, like I said, you want to figure out the charges on the ions that make that compound. So permanganate should be feeling more comfortable with polyatomic ions now. You should be able to find that it's MnO4 is -1. Okay, now you want to compare the charges. Here you have opposite charges, a +1 with a -1. So it would take one cation and one anion to make a formula that's neutral. So when you combine these into a formula, you'll have KMnO4, and it just takes one potassium to one nitrate. Okay, and there's your answer. So it's 1 to 1. And you're done. Now, this is just to show you that's actually the formula. Let's try another example. Okay, barium chloride. Okay, again, you should know the symbol for barium is Ba. You should know the symbol for chlorine is Cl. Now, when you think of the charge on the ions, you should be able to predict both of these. Okay, you should know that barium has a charge of +2. Chlorine has a charge of -1. All right, so now you have both ions, the cation and the anion. When you put them together in a formula, BaCl, you have to figure out if there's any subscripts. So again, you need a formula that's neutral. So if you look here, a +2 and a -1 would not add up to 0. In order for this to add up to 0, you would need to have 2 chlorine or 2 chloride ions. That would give you a -2, and then you would see, well, -2 and +2 is 0. Okay, so since you need the 2 chloride ions to cancel out that +2 charge, your formula is going to be BaCl2. Okay? Let's try another example. That one was type 1, by the way, again. All right. Okay, so now you have copper 2 nitrate. So here you have the name with a Roman numeral. That should be a dead giveaway that this is a type 2. Okay, so now when you write the ions, copper is going to have a charge of +2 because that Roman numeral tells you the charge on the cation. Nitrate is a polyatomic ion. It's NO3, -1. Okay, again, when you put these two ions together, you end up with CuNO3. But if you look at the nitrate, that has a charge of -1. You need to make it so that they're opposites. So it would take 2 of these nitrate ions to make a -2, and that would cancel out the charge of +2. So you need opposites. So here, put the nitrate part in parentheses and then put a 2 there. So that's your formula. So you need 2 nitrates to 1 copper to make your formula work. Okay, that's the only way that you'll end up with a formula that's neutral. All right, so there's your answer. Next. All right, so lead 4 oxide. Again, Roman numeral. So again, you should be thinking type 2. All right, so if we write the symbols here, Pb is lead. Oxy or oxide, that comes from oxygen. Okay, the Roman numeral tells you the charge on the cation, +4. Okay, so for oxygen, you should know that an oxide ion has a charge of -2. All right, so here, you're going to end up with a formula that is PbO. But again, in order to have a neutral formula, you're going to need 2 oxides. That'll give you -4, and that -4 will cancel out the +4. So you need 2 oxygens to every 1 lead. And there's your formula. Okay, let's try another one. Okay, dinitrogen tetroxide. All right, so now this one is a little different. Here based on the first part of the name, you should see that this is nitrogen, dinitrogen. And then tetra, oxy, the root here is oxygen. So you have a formula with nitrogen and oxygen. So here, you can see they're both nonmetals. So you should be thinking type 3. Because type 3 has nonmetals only. All right, so now that you know that it's type 3, you have to use these prefixes to help you figure out the subscripts. So di means 2. Okay, that's a prefix for 2. 2 nitrogens. Okay, tetra is a prefix for 4. So 4 oxygens. So you're done. The prefixes, once you figure out that it's type 3 and only has nonmetals, you know it's a covalent compound. Well, the prefixes help you figure out the rest. Okay? Done with that. Let's move on. Write the formula for lithium sulfide. Okay, so let's see. Lithium sulfide comes from sulfur. Okay, so you have metal and a nonmetal. So lithium is forms an ion that we can predict. So you should be thinking it's type 1. And then you could predict this to have a charge of +1. Sulfide you can predict to have a charge of -2. All right, so when you write this, when you put this together into a formula, you have LiS. Again, your charges have to cancel out, so you need 2 lithiums to give you a +2, and that'll cancel out your -2. So Li2S. And we're done with that. Okay, carbon tetrachloride. All right, so you have a carbon, which is a nonmetal. Tetra and chloride. The root part tells you that that's chlorine, so you have carbon and chlorine. Okay, there's no prefix here for carbon, so we leave that alone. Tetra means that there's 4 chlorines. So if we put this into a formula, it's 1 carbon to 4 chlorines. So you got to remember with the type 3s, you got to figure out, of course, this is type 3. Non-metal, non-metal. So with the type 3s, you don't use the prefix mono on the first non-metal. So if you just see the name of the element, that just tells you that it's 1 carbon to 4 chlorines. Okay, let's try the next one. iron 3 sulfate. Okay, Roman numeral. Again, type 2. All right, so if we break this up into ions, you have iron, Roman numeral tells you it's +3. Sulfate, you should be thinking polyatomic ion, SO4 -2. Okay, now this one's going to be a little trickier. You have to figure out, kind of like you can think like a math term, the least common multiple. What's the least common multiple of 3 and 2? Well, it's 6. Okay, so it's going to take 2 of these irons, of these iron cations, to make a charge of +6. And then it's going to take, here, let me move this, 3 of these sulfates that have a charge of -2 to make a -6. So you still want to make opposites, just this one gets a little confusing because you have to find like the least common multiple. All right, so when you put this together into the formula, you have an Fe, you have an SO4. It's going to take 2 irons for every 3 sulfates. So put sulfate in parentheses and then a 3 outside. And there's your formula. 2 irons for every 3 sulfates. And that'll give you a neutral formula. Okay, done with that one. And that's it. All right, so it takes practice. It takes being able to recognize what type of compound you have, and learning the polyatomic ions, learning the common ions. It takes time. So I hope this was helpful to you. See you next time.